Hello everyone, I'm Xiao Gang. Now we are going to do this hands-on practice. Now we still need to create our flake. Here we will still perform a simple initialization operation. We should be on our 10th case. Let's call it ComBand-Undo. Collision, it should be written like this. Let's not write it wrong today. Yes, because if it's written wrong, it might not be good, okay? Then this part should be done like this. It should be. Let me check if this level is correct. No, this level, we need to delete one again. For example, level, we need a basic level. Okay, let's save it. Note that you must click this to save. Let's call it level component and fill unity combine and correlation. Okay. Then let's delete the previous one. After specifying it, we'll still work in the editor. A quick and simple modification. Later, these modifications, we'll just cut them out because you should be quite familiar with this kind of operation. But we'll still try as much as possible. In the first part, to demonstrate it to avoid skipping content. Then here, we'll create a new pump, and obviously we can create it here. We can go here, take a look. This pump, this is our gameplay architecture. Then during the interview, actually many interviewers will ask you about excellent gameplay architecture. Then you can just ramble on about it. Then concepts like game mode, game state, and that's it. And if you can handle it, you can also talk about this thing called game feature and so on. Then you can also talk about the UI architecture, how it interacts, and how the data layer is designed, why it's designed that way. Then talk about JS components. These the audience will think you have a solid grasp. The comment here. Okay, let's put it here. We don't need BP here. Let's add an XG. Okay, let's create it. Although it's actually already created, it's created here. Actually, we still need, let's eagle lot first, then we'll create it here. Our movement component, because we might need to write both things together, so I don't have to jump back and forth. The movement component should be here. Then you might need to write movement. Actually, we haven't talked about it yet. Our character will cover it later, because the character is actually more complex than this pawn. Because some friends might directly look at our third person or first person official template and jump straight into the character. That would actually be a bit confusing. And this movement component, let's see what name is more appropriate. For this movement component, we'll call it this name. You see, there's actually a hint here. You see, the castman must not lower longer than 32. You must not exceed 32. And we also do not recommend writing it directly. Writing it directly will cause problems because there is a maximum path limit. The issue is that if it is too long, the path for the disk operation is already very long. You will find that this path in some SDK or third-party library cannot be recognized. So this part will directly give you an error. Actually, it won't give you an error. You just won't be able to perceive this error. This is even scarier than an error. You will spend a long time debugging. You will find that this thing of yours, if it is in another project, you can still use it, which is fine. The worst case is that you search for a long time and still cannot find the reason. So this is a piece of experience, because I wasted a lot of time here verifying this path issue. Of course, you can use some restrictions to modify the maximum path limit of windows, but in fact, it is not very meaningful because the environment of each computer may be different. So by default, this place has a potential issue like this. That's fine. This is a common point to check. Okay, after we have such a component here, then we need to create our example backing. Actually, the way it's written here is not very standard. We will have a standard way of writing it later, but we won't write it now. Writing it this way in Blueprint, you actually can't see the component at all because it's hard-coded. Note that this is a null pointer. This is a forward declaration. Then in our source file here, let's just copy it over directly. Because these are all things we frequently use, what are you explaining to everyone? But one thing worth noting, we could take a look. This thing is called the particle example. It is inside the engine, so it should be fine. It shouldn't be a big problem. One thing to note, if you use Niagara particles, you might need to add. In our build, 查一次, add the Niagara particle module. It should be like this. There will also be such a situation. Then we can see how it is written here. It's a bit hard to describe. It is written like this here. It is written like this. Didn't you notice it's not in the same naming convention? Since it's not named, we'll just ignore it. The correct approach shouldn't be written like this, because if you write it this way, the blueprint can't be modified, that thing. But for us programmers, it would be written very quickly. Then you see what it is. Right, it is in blue. It inherits this. It is actually our collision component. We'll write this and show you later. That is our spherical collision box. That's it. Then specified its collision file. And here, there should be no problem. Then here, it also declares a static mesh. Static mesh. And in the static mesh section, it attaches it to our root node. Why is it not being recycled here? It's because of this place. You'll find there's an up upper P here. There's an up upper P on this actor. So doing it this way means it won't be reclaimed. But if I didn't tell you, would you have thought that after I do this, whether it would be reclaimed? Right. And after you attach it like this, when it attaches actually, because you attached it, it's essentially holding onto it indirectly. So in fact, it won't be reclaimed either all along this chain, and then you specified the root point. Then it won't be reclaimed. So here, a mesh component is created. And then here, practically it uses this hard-coded method again. Using a hard-coded method is really not reasonable. It shouldn't be done this way. This part is still understandable, but I think the hard-coded method is not reasonable. If this part loads successfully, then set this thing into it. Pay attention. This object PTI will be used later, but for now, you can directly think of it as a pointer. That's fine. It just points to this resource. Do a size adjustment inside here, or some corresponding matching settings. Finally, we will create this particle system. As for the particle system, actually, I will show this to everyone today. If a particle system is created here, then pay attention to the particle system here. It also needs to be activated, so there is no problem. Set the relative text. It wants to rotate from the side. Finally, specify this template. And this is the bounce B component. There shouldn't be any benefit either. Let's try to be quick. Otherwise, it will take too long. Okay, so that's the related settings after finishing the discussion. Finally, create the actual camera, because we have already explained it in detail earlier. So at this point, we need to start it up. Let me show you what our blueprint looks like now. And actually here, go to we should have it. This movement component. You will see the component looks like this. And here, we create a blueprint class. put it in this position. After creating it, we can see that it is right here. Obviously, this is loaded through this constructor. This is the initialization. Then we can observe, actually, in this place, this is a collision box. Actually, it is sphere calculation. Although it is called rule combo, its actual type is here. Then you will find this property. You will find that none of these are here. Sometime you will encounter this kind of problem. In this case, you can try to solve it this way. If everything is set up correctly and you still encounter this issue, you can create another blueprint. Let's just drop it under content. Let's take a look. You will notice it's still the same. That proves that this way of writing might not have been exposed, but sometimes when you properly expose it to the same file to hook your property, then you recreate a blueprint class. Maybe this blueprint class was not processed correctly. Let's delete that one. We didn't use this one. Okay. Then let's continue looking at it. If you can't see it here, actually we can create a new Sophia here. Take a look. It should be this one. It had some properties here. Actually, it's here. There is one here. Here, preset. Set it to Punk. Then here, for different detections, it will respond and update with some main color settings. Actually, if we have an example here, it should be called particle. This should be it. We like to call this cascade example. This cascade example is here. There is a temp variable. The actually point, you will find this file. Let's click on this file, copy its reference. Let's paste it here. This file is actually it. You see, it's this path. As for this share, we probably don't need to demonstrate it to you. It's this path. Take a look. It is a ball. We can directly reverse engineer this path. It is inside chips. Chip file. Let's look for it in chips. Alright, chip file is the one. Okay, then let's continue writing below. Before we continue writing, let's take the components we added and delete them to avoid causing some conflicts, so to speak. Right. Delete them. This should be this one. This way, it's normal. Okay, you probably can't see it like this. You can ignore it, because our writing style is a bit strange. So you can ignore it. Then let's continue to check whether there is any problem with our mapping. Is it here, or in our predict 3.0? Here in our input section, you will see that we still have move forward, move right. Pay attention here. If your names are different, the binding might not have been applied. Then we have an X here. Let's rewrite this X again. This looks like a misclick. Oh, we can still Ctrl+Z. If I sign out like this, you might run into problems later. There's a ton. Then let's add a moth X here. Okay, no problem. So for this front and input receiving part, we still need to add a space. Let's call it, pay attention to the spelling here, pickle. This part is easy to misspell, and never type that kind of. Do not add spaces within this string. This is our unconscious behavior. Yes, but in some places it will be added, but you can't avoid it. But when you write code yourself, never add this space. I want to emphasize this to you again, because it's very important. Then we have already finished this part. Then we go to create movement component. We have already created it. Now we start writing the code for the movement component. We are almost there. Actually, our current movement component, it is not yet connected with it is attached to it. We see this movement component. It inherits from the level move complex. It can update the movement. And it also provides methods to accumulate and follow this direction. These common genetic methods So the main one used is this method. This is the input vector we added. And then consume it. And here are some methods. Look at this method. We can specify which long path component to update. Generally, updating our main component is adding right. Then these methods, you can get some final stuff. Get what is being cached. It consumes it. And this is whether it has been ignored. Get who owns it. Then these U methods are relatively important. Then here is some information about owners and controllers. Then we can look a bit further back. Then here is a very basic thing. Actually, when we are doing UI, there's a problem when you use UI. You find that when you are in UI AM02, the UI animation difficulty did not take effect. Why is that? This is because its navigation component may not have this enabled. This kind of speed, that is got a speed, then you just need to enable this navigation component. Such a function will do. Take a look. If it is a restart method, this might not be available. It could be. You can see it inherits from the wood component. Ultimately, it inherits from the wood actor component. There are quite a few properties in the actor component because it provides many common built-in methods. This method is very important. We will discuss this in the context of online games. This will be for our single-player games. This mode is exclusive to online games. This mode is for RAN multi-A. This is the client. You can think of it this way. It combines this mode with the character. This kind of division, it might be a bit more complex. Let's find it here. There should be a tick. We mainly need to override this method because we need to execute. Some games we define ourselves. So in this place, obviously we can just copy it over directly because this function's signature has override. So we must go into its actor component. This method must remain consistent. Now we perform a consumption inside it. So actually this serves as a bridging role between the front and the back. Obviously, we must execute the parent class's method, right? Execute the parent class's method. We need to ensure that everything is valid. First, this owner, you can see the owner is inside here. So it only takes effect when there is an owner because it drives others to use it. And this is a new component. It is a TOP. That is, you are pointing to this updated component. It must also take effect, and here is whether to skip the update. Then some judgment may need to be made here. It may verify whether this time it is necessary to update this thing. If not skipping, if it needs to be skipped, we just skip it. It is the collision that the engine handles for us. And here we can get our variable. It is the one we added earlier. Look here. Consume it, then the value it returns as an actor. It might be the value you input, then we made it into some. Essentially, we applied a restriction. Then the restriction, yes, now we still need this maximum size. It might be that we only want one direction. Yes. Then this part is a simple temp related scaling. It becomes a scaling factor. Then, as long as this is not 0, then we need to perform a movement. So how do we perform this movement? We use this method. What is this method? It is this method inside MoveComponent. Yes. It needs to perform a safe movement detection. If this thing, if it gets collided, if it gets hit, we may need to do the attempt will be blocked. Then we add a bit of this method. Do you see what this method is? This is just testing whether it can be passed through. You see, this is the attached type. Some methods that cannot be provided. None of these methods were written by us. We can call them to use them because the engine has already written them for us. We just need to, at the right time, at the right place and location, to use them. So actually the simple movement component has been written for everyone. After the movement component is written, then we need to associate them because currently the two only have names. Now only the names are the same, but they haven't actually established a connection. Right, okay? Now let's make them establish a relationship. And this actually matches the normal development process. We finish writing the functionality of this component. Then whoever uses this component, we need to complete a registration for it. An initialization. And during this process, it becomes very complicated in networking because timing issues are involved. it's very likely that this actor already exists, but one of its components hasn't been created yet. Then if you directly call a method of this component inside the actor, congratulations, if you manage to protect it. Then this call will lose its opportunity. Then this call will fail. But there may be no error reported. No prompt if you make a retry attempt. And then design a delay. Then this call can take effect. But its design is unreasonable. The correct approach in networking, you may need to architect an intermediate layer to design an overall framework for such delay design. Well, this is quite complex. We won't go into an in-depth discussion here. So first of all, we add such a component here, because after adding this, obviously this thing is wrong here. We need to change this name. That's fine now. Okay, let's continue looking further. Actually, this is a bit verbose here. Then here, actually, we need to discuss the forward declaration. Then, when we need to use it, we need to include. Personally, I prefer to do it this way, like this, because I like to separate what I write from the engine's files, or leave a gap like this. You can control it. This should mean the inclusion was successful. Okay, no issues. So after we include it, we need to create it in our constructor. So we'll just put it here to load it in, because this is a logic component. So I like to call this component 1 that specifically writes this kind of business logic without any instances. So we need to specify it here. So add a U. Okay, this is our custom movement component. We created it and specified that the root node it updates is this one. At the same time, we need to override a method like this. So where does this method come from? We can look for it here. We can look for it here. You will find that this method is a U function. And it is here. So when we override it, we don't need to write this U function, right? We can click to take a look. This place. This is done to reflection. You will find that it is usually found through reflection. This way of writing is quite interesting. That is, this more advanced way of writing is often said to be, yes, we can generally override it. We won't let it find this thing through reflection. We need to confirm its access level in a moment. It is a public access level. Then we write it to this position, because we have already created it in the subclass. And here we just need to return this pointer back. And it will usually help you with implicit upcasting, because upcasting is always successful. Remember this point. Next, let's write some of our binding methods. Yes, the binding methods here. Actually, you can just write it like this. But note that sometimes when binding, we need to add a U function type. Because some dynamic bindings must use U function type, it binds through reflection. It must expose this to blueprint. Expose to the engine that there is a reflection method here that needs to be bound. You'll need to do some processing. Then in the move 4, our processing is relatively simple. So mainly, as long as our component is successful and the root node has been specified, we directly call this function. This function, we take the input we want to add and create it inside. Then here it means, take the given vector as an accumulated input. Accumulate the input in world space, and usually it is actually 0 to 1, and they do it through equivalent to firm, frame by frame. Then it can be made into this kind of acceleration when this module moves and updates. Then this is the words. If this is false, if it is forced to add, then this will be ignored. That is the module implement angle. That is, whether to ignore this thing this time, the default here is false. So it is like this. We can see it is here. Then, obviously, this is left and right. Then just stop. Then the ter here. Then ter means rotation. We can make this place. Just directly rotate the root node of this actor. And then here, we need to activate. This particle component is just to set up this fire. Then active and toggle this activation. You can see this is active component. It is a method of the parent class. Actually, it is overridden in this actor. Within this particle component, toggle active. You can click into it. We do it like this. Actually, it is overridden. So this can turn this fire on and off. So in this case, it's actually already done after startup. Then we need to do a simple link in between. We usually just put it here. We do a binding. We just cobra it directly. Let's check carefully, because if you write it wrong here, I need to change the name. If you write it wrong here, it won't bind. So these binding methods are the methods we just wrote, and there's no issue with them being unused. Think about it. Actually, at this point, we've finished writing all the code. Then let's run it. Let's see what the effect looks like. Okay, we have already started it up. And our map is also correct. And because our part here is AI post spy, so we need to specify it. We are not having it generated through this game mod. You will notice, because we are not specifying it through this order 30, this default punct class, we are having it have an A2 here. You can see there's actually nothing here. But it actually has a lot of things because it is let you cannot see the person. So you won't let the blueprint change it. It's just that I need to test conveniently. Let's start. You'll see, right? We emit flames. See, this is such a simple one. Hey, we can also rotate it. Then we can add some art pieces into the scene. Let's put this thing in. We'll place it where our blueprint indicator is. Let's put 2 pillars here. We'll try to make sure it touches the ground. Touch. Touch. Okay, let's take a look. And here, hey, you can see I only pressed forward. I only pressed forward. This is called slip. Let's just slide over. Okay. I press the clamp like this. Oh, right. This is a very interesting functional point of our custom component. Good. This lesson has gone on a bit long, over 20 minutes, but it is still a very important. And basically, there is still a certain distance from actual development. But as our course progresses, we will show you more mature, more standardized writing practices. Okay, so that concludes this lesson. Thank you all.